The third way we're going to learn how to solve quadratic equations is by completing the square. So by the end of this lesson, you should be able to solve a quadratic equation by completing the square. So let's talk about what that means when we say completing the square. We have these things called perfect square trinomials, and perfect square trinomials can be factored to look like this. Something plus something else all squared. So it would be something like x plus 2 times x plus 2, and we would rewrite that as x plus 2 all squared. So if we have something like this and I want to distribute it out, what we learned in 8th grade was that we could write out this into a square, and we could multiply the squares together. So here would go x times x, or x squared. Here would go 4x. Here would go x times 4, and 4 times 4. And we've made a perfect square because the length and the width are exactly the same. And inside this square is x squared plus 8x plus 16. Now if I asked you to factor something like this, it should be plus 36. If I asked you to factor something like this, we could do the same kind of thing. We could fill out this box, and then we could see what each row has in common and factor it out, and each column has in common and factor that out. And we did this last year, but just to refresh our memory, so x squared goes in here, and 36 goes down here. Now, we can quickly see that it's x and x to give us x squared, and 6 and 6 to give us 36. So in each of these boxes here, we get a 6x, and that's where this 12x comes from. Those two are always going to be exactly the same. So the relationship here that you need to get out of these squares is that this right here is always x times x. This number right here is your last two numbers together. And these numbers here and here are whatever's in the middle cut in half. So whatever's in the middle cut in half. This was 12, 6, this was 8, so 4. So find the value of n such that each expression is a perfect square trinomial. So we're trying to fill in a square, and we don't know what we have missing. So we have a k and a k to give us k squared. And then we have 14k. So that means in this box we would have had 7k, and in this box we would have had 7k. So because we had a 7 on both of these sides, we end up with 49 would be the number that completes the square. And if this is the case, this thing can be factored into k plus 7 all squared. Let's try the next one. So we have an m squared, so that means we had an m times n. We had a negative 8 here, so remember we're cutting that in half, so negative 4m's would go here. So then we can see that that means this would have to be minus 4, and that gives us positive 16 in here. So 16 is the number that completes the square. And then if we wanted to factor it, it would be m minus 4 squared. And we try this last one. We have y squared here, so we know that was y times y. Negative 40, so we got to split that up. So negative 20y is here and here, because remember, we want this to be a square, so we want to split that 40 up right in half. And if you do 20 times 20, you get 400. So 400 is the number that completes the square. And if we wanted to factor this, it would be y minus 20 all squared. So how in the world does this help us with quadratics? Well, let's say I gave you a problem like x squared plus 2x equals 0. Hopefully you could factor this by pulling out a GCF. And then this means we got two things, they're multiplied together and they equal 0. So I could say x equals 0 or x plus 2 equals 0. And this right here is already a solution. But this, I'd have to subtract 2 to both sides, so I get negative 2 as my other option. So that's how we did it yesterday. But now, if we think about filling in a square, we can solve this exact same problem and get the exact same answer a different way. So let's fill out the square. If we have this, we have an x squared here, so we know there was x times x. Just like before, we got to take this term and we got to cut it in half. And that tells us what goes on the edges of each square. There's got to be a positive 1 and a positive 1. So 1 times 1 gives us 1 down here. This 1 completes the square. So now we can't just go adding a 1 wherever we want unless we do it to both sides of our equation. So that's what we're doing down here. If we add 1 to both sides of our equation, we end up with this. That's exactly the same thing as what we started with. Because if I was to subtract 1 from both sides, this would cross off, and so would that. So x squared plus 2x plus 1 equals 1 is our new equation that we're going to be working with. And now if I factor what's on this side, remember I use this to make a square. So my factors are x plus 1 times x plus 1 or x plus 1 squared. And that equals 1. So now this goes back to the square root lesson that we did. I can solve this by taking the square root of both sides, and I get x plus 1 equals positive 1, and x plus 1 equals negative 1. And then we can solve. And we end up with 0 and negative 2. So the exact same two answers that we did here. Now obviously factoring is a little easier for a problem like this, but when we get into different problems, completing the square is going to be a little easier. So here's your procedure for completing the square. You write the equation in this form, so you leave yourself a blank on both sides. So unlike factoring, you don't want it to equal 0. Complete the square with half of b squared. So if you looked back here, the pattern was you take this number, you cut it in half, and that goes here and here. And then you square that number. So 2 divided by 2 is 1. 1 squared is what's right here. That happened back here as well. So you take this number, you cut it in half, so that's where 7 came from. And then you square 7, and that gives you 49. Take this number, cut it in half, you square it, and that's where 16 came from. Same thing with the next one. Factor the perfect square trinomial, and then take square roots of both sides. In this step, make sure you take both square roots on the right side. So this is b over 2 squared. So I know this kind of seems like a lot, but once we get going on it, it's pretty easy. So if I want to solve this equation, it's already in the format that I want. Just going to leave myself a blank. And then I have to fill in that blank. So remember, I want a perfect square. I want something that when I square it is going to give me m squared minus 6m plus something. So an m goes here. Remember, you cut this in half, so you get a negative 3. And then you square this. So negative 3 squared is positive 9. Whatever you add to one side, you've got to add to the other. We can't just go adding random things places. So you end up with 256. Now remember, this thing right here that we got is our perfect square trinomial. If we had m squared and negative 6, we'd have to split it up. So this would give me negative 3 and negative 3, and then we squared that to get 9. So that's where the 9 came from that we had to add to both sides. And then this part here is what it factors into, m minus 3 squared. And now this is easy to solve because all we got to do is take the square root of both sides. So I get m minus 3 equals, square root of 256 is plus or minus 16. So set yourself up 2 equations, and then you can solve. So 19 is one answer, and negative 13 is an answer. So let's try another. Solve this equation. So I'm going to set it up, give myself a blank, and then I have to make this a perfect square. So I kind of like to cheat and do two things in once. I have to cut this in half, so I get 9 halves, or you can write it as 4.5 if that makes you happy. And then you have to square 4.5 to go in the blank up there. So 4.5 squared gives you 20.25. And we can't just go adding that to one side, we got to add it to both. So this equals 156.25. And now we get to take the square root of both sides. So we end up with x plus 4.5 equals 12.5. And remember we had plus or minus there. So set this up into two equations. X plus 4.5 could also equal negative 12.5. Now if we subtract 4.5 from both sides, we get 8 as one of our options, or 17. Negative 17. So sometimes they're not going to be as easy because they're going to have a number out front. And in order to solve this number out front issue, what we have to do is divide by that number out front. And we have to divide everything by that number out front because you cannot complete the square with a number out front. And luckily for this problem, everything simplifies nice and neat. And then we just do the same thing that we've been doing. We want to turn this into a perfect square. So you take that number, -2, and you cut it in half, and then you square it. Whatever you do to one side, you got to do to the other. So now this, we can take the square root of. So we end up with a minus 1 equals plus or minus the square root of 7. And then, because this is a square root that we can't simplify, we're going to leave it for right now. We're going to add 1 to both sides. So a is 1 plus or minus the square root of 7. And since we can't do anything more with this, we're just going to leave it. If you wanted to, you could figure out what the square root of 7 is and then add 1, and you'd get 3.65. And you could do 1 minus the square root of 7, which is negative 1.64. But on your test, I'm going to ask you to leave it in simplest radical form. So this is the answer I want to see for full credit. All right, so this problem here, the first thing I notice is that it's not in the form I want it to be in. So I got to do two things. I got to get this 15 over to the other side. So you get 5n squared minus 3n plus our blank equals 25 plus our blank. And then the next thing I notice is there's a 5 out front, and that can't happen, so I got to get rid of that. So this gives me n squared minus 3/5 n plus our blank equals 5. And then the steps are exactly the same. So we got to turn this into a perfect square. So what I'm going to do is cut this in half, and that gives me negative 3/10. And then we can square that, and you end up with 9 on top and 100 on the bottom. So that is 0.09. So this equals 5.09. And now we can take the square root of both sides. 3/10 is just 0.3, so we could write it like that if you wanted to. And the square root of 5.09 is about 2.2561. Remember, there's a plus or minus on here, so you technically have two equations that you can solve. And the two answers you're going to get are 2.556 here. And if you add a negative 3 to this, you're going to get negative 1.9561. Those are your two answers. Because it says to round to the nearest hundredth, I would say for this problem your answers are 2.56 and 1.96. Call it a day. So I left you one problem to do on your own. It has one with a number out front, so make sure you take care of that first. I'm sure you have tons of questions, but we will go over this in class tomorrow. Enjoy your night.